Good morning students. Today we are going to discuss few important topics from chapter 3, and chapter 3 is your motion in a straight line. Now the first topic which we are going to discuss is your position time graph. Now if you see the graph, number one graph is for the stationary object. Now along y-axis we have considered position axis, and along x-axis we have considered time axis. Now you do have a graph AB. Now the graph is a straight line and it is parallel to the time axis. So if you see from the graph, you can conclude that with time there is no change in position, and it means that the object is at rest. So if you consider time t equal to 0, its position is x0, and if you consider any arbitrary time apart from 0, you will see that the position is still x0. There is no change in position. So whenever this kind of graph you will get and the graph seems to be parallel to the time axis, then you can conclude that this is the graph for the stationary object. Now next graph is for uniform motion, and again it is position time graph, and the graph is passes through the origin and it is a straight line. So I think you can find the velocity or speed from the graph by considering any two arbitrary points from the graph. Now if you consider any two arbitrary points, what you have to do, you have to draw lines parallel to the position axis as well as parallel to the time axis. Then you will get a triangle, right angle triangle, and from the right angle triangle, if you find the slope of the graph by considering tan theta, then it comes out to be your perpendicular by base, and that ratio is nothing but is your speed if you consider position time graph. If you consider displacement time graph, it becomes your velocity. I think you have done this one in lower class, maybe class 9. Now next one, what we will do, again it's a graph considering position versus time, but this graph is a straight line with a negative slope. Now when this kind of graph you will get, it shows that at time t equal to 0, its position is your x0, but as time progresses the position decreases with respect to some reference point, and ultimately the position goes to 0. So this is some kind of negative slope graph, and basically this is some kind of a motion due to some retarding force. So more becomes clear later on, but you try to understand this part for the time being. Now next one, what we will discuss, that is your velocity time graph. Again it is a straight line. Now velocity time graph, it means is your constant velocity. The object is not at rest, rather it is moving with a constant velocity, but this one seems to be at rest. With respect to time, the velocity does not changes, and the graph is your AB. So you can consider any two arbitrary points C and D from the graph, and from that point you have to draw a line parallel to the velocity axis. Now if you consider this rectangle, you can find the area, and the area gives you the product of velocity and time. So velocity and time product is nothing but is your distance or displacement, you can say. So again let me go for a non-uniform motion. Already you know what is non-uniform motion, you are not supposed to define here. Now non-uniform motion graph is basically your curve. So from the curve you can define average velocity. Now that is your displacement axis is your y-axis, and time axis is your x-axis. Now as the motion is non-uniform, that's why there is a need to define average velocity, because velocity does not remain constant, it changes. So for that, what you will do, you will consider any 2 points A and B from the graph. Now you have to draw a line such that AB should be your straight line. Now you have to draw a line parallel to the displacement axis as well as parallel to time axis. So you will get a rectangle, a right angle triangle basically, and from that right angle triangle you can define the change in displacement with respect to the change in time. So this change in displacement with respect to the change in time gives you the average velocity, and already we have used this formula in our numericals in last class. So VAV of average velocity, del x by del t, x2 minus x1 by t2 minus t1. Now I think all of you know what is the use of finding average velocity. If the motion is non-uniform, then you have to find the average velocity, because the velocity does not remain constant throughout, no? If the motion is non-uniform, that's why there is need to find the average velocity. Now you can define instantaneous velocity also, because velocity at every instant changes. So if you have to define instantaneous velocity, then you have to consider this limit delta t tends to 0, because if you consider delta t tends to 0, then a and b seems to be very close to each other. But you can assume that a and b is very close to each other, but it is not coinciding. Rather, you can assume regarding the time that it is a time for a particular instant. So that's why you can use this formula, limit delta t tends to 0, delta x by delta t. Now this formula you can merge with this formula dx dt, that is a differentiation of x with respect to time. So already we have defined in case of instantaneous speed. Now it is in case of instantaneous velocity. So what's the difference? There is a position time axis or distance time axis. Here is the displacement time axis. That's all. Now next point or the next topic which we are going to discuss is your relative velocity. Now you see, all velocities are relative to each other. There is no absolute velocity, because Earth itself is moving, no? So when you have to compare your velocity with respect to some reference velocity, then that velocity is your relative velocity. So let me read out. Relative velocity of one object with respect to another object is the velocity with which one object moves with respect to another object. So you are with respect to some other object, and if you consider a velocity of a particular object, definitely you have to consider with respect to Earth, because Earth is also moving, no? So hence relative velocity is the time rate of change of relative position of one object with respect to another object. WRT is your with respect to. Now you see this explanation part here, as we are discussing motion in a straight line. So we will consider one-dimensional motion. So you see, you do have two objects, A and B. Now initially at t equal to 0, its position is your x01 and x02, and both are moving with different velocity, that is your v1 and v2. Now as time progresses, let you consider t equal to t, its position is your x1 and x2, but the velocity remains same, v1 and v2. There is no change in velocity. So few equation you can define from here. One is your, if you consider x1, then you have to define x01 plus v1 t. And number 2, if you consider x2, that is your x02 plus v2 t, because you have to define this equation, and it's a very simple. I think you have understood. Velocity into time, displacement, or speed into time, distance. That's formula, s is equal to vt. Now simple mathematics, x2 minus x1, x02 minus x01 plus v2 minus v1 into t. So x2 minus x1, we have considered x, and that is nothing but the relative displacement of b with respect to a at t equal to t, because b is your x2 and a is your x1, b is your x02 and a is your x01. Similarly, x0 equal to x02 minus x01, so this gives you relative displacement of b with respect to a at t equal to 0. So if you shift the parameter x minus x0 by t equal to v2 minus v1, so x minus x0 by t gives you relative change in, or you can say relative change of rate of change of relative position of b with respect to a, rate of change of relative position of b with respect to a, and this one is your relative velocity of b with respect to a. So that one is your VVA, basically relative velocity of b with respect to a, basically denoted as your VVA, that is your v2 minus v1. So similarly, if someone asks you relative velocity of a with respect to b, then you have to define v1 minus v2. So this is all about. Please go through this topic. This topic is very important, and there are many numericals, and we'll try the numericals as well as important topics or important points from the numericals or from the chapter. This is all about. Please go through this topic and find out your doubts if you have. Make your habit to ask questions during that class. Thank you.